Hello, in this video I'm going to recap some of the rules of probability that I've discussed in some previous videos, so we can kind of just have everything in one consolidated list. So the first rule of probability said that the probability of any event is always going to be between 0 and 1. And remember, 0 means that something is impossible, 1 means that it's certain, and if you'd rather, you can have these as percentages. The second rule says if you take the probability of individual outcomes, of all the individual outcomes, and add them together, you're going to get 1. Thirdly, we have the complement rule. And this says if you want to know the probability of a complement, you can just subtract the probability of the known event from 1. And as a reminder, this comes in really handy if you construct an event with a lot of items and the only thing left in the complement is maybe just 1 or 2, then often it's easier to subtract a probability than to add up a whole bunch of others. Let's see. We also have the addition rule for disjoint events. So I'll say those are E and F. And so in this case, if you want to know the probability of E or F, you can simply add the probability of E with the probability of F. And then we have a general addition rule, which says if you want to know the probability of E or F, you can add the probabilities. But you may have to do a correction if there's some overlap. We'll have to account for that and subtract the probability of E and F. Let's see, we also have a way of calculating conditional probability. So that's the probability of E given F, and this is the probability of E and F over the probability of F. And you could write this of F given E, and it would just change the denominator to an E, probability of E. And we can rearrange this to say the probability of E and F is the probability of E given F times the probability of F. And then finally, we have a test for independence, which says if the probability of E given F equals the probability of E, then E and F are independent. So let's look at an example where we can pull all of these together. So here I have a cross-tabulation. Some data was collected from a sample of 530 participants. They were asked whether or not they used social media, and they were also asked their age. So there are two variables presented here. So social media, but I think yes or no, and then this was the age they could identify in one of these age groups, 18 to 34, 35 to 44, and then for these two others, 55 plus. In the last column here, this is a total for social media use, and then in each column we have a total for each age group. So those are the last values here, and then this is our grand total. So I want to use this in our rules of probability to answer some questions. First, let's define some events. I'm going to define event A. So let's say that we're going to pick somebody random. One event would be that we would choose somebody that does not, or let's say that they use social media. So we will select someone who uses social media, and then for event B, Let's say that we'll select someone 55 plus. So here are the questions I want to answer. Let's find the probability of A, the probability of B, the probability of each complement, and see what that means. We'll also want to do the probability of A or B, the probability of A and B, the probability of A given B, B given A, and then lastly we'll answer our A and B independent. And we'll kind of give some justification. Alright, so let's look at the first one, the probability of A. So A is, we would select someone who uses social media. So this row, these are the people who use social media. And notice there are 338 of them. So we would have a chance, there are 338 out of 530. And using my calculator, 338 divided by 530, I'm going to just round this and say that's about 64%. So for B, this would be I select someone 55 or older. Well, there were 115 of those people out of the 530 in the sample. And so 115 divided by 530, and again I'm going to round just to a whole percent, so that would be about 22%. So A's complement would be, A was that you use social media. This would be that the complement would be that you don't. And so there are 192 out of 530. And if that's easy enough to calculate, 192 divided by 530. 192 divided by 530. And that's about 36%. And notice that that's also, I'm going to say 1 minus 64%, or 100 minus percent minus 64%. So I could have used the complement rule here. And in fact, that's what I want to do to find the probability of B's complement. That's 1 minus the probability of B. And so that's 1 minus 0.22, that's 0.78, or 78%. 78% and 22% add up to 100%. Now the probability of A or B. So A is that you use social media, so that's this group. And B is someone's 55 or older. That's this group. And so what I mean is that you could be either one of those. So I'm going to do a Venn diagram here just to make sure I keep this straight. So I've got my use social media, and there are 338 of those people, and I have my 55 or older, and there's 115 of those. And in the overlap, I know that there are 49 people who are both. They're 55 and older, and they use social media, so these are 49 people. So when I say A or B, what I'm doing is I'm actually kind of making a super set here, where it's combining, like in a marriage, these two elements. So instead of having two separate events, the OR statement combines those into one thing. Now, if I see how many people are included in this marriage. Well, there were 338 who were users of social media, and 115 who were 55 and older. But within that 338, I counted these 49 people, and again in the 115. So this is where I need to subtract off the 49. Now, you can do this, let's see, I'll just do this with my calculator. Clear 338 plus 115 minus 49. So that's 404. And this is out of the 530. So notice what I did here is I took the probability of A plus the probability of B and subtracted off the probability of A and B. So this was the 338 out of 530 plus the 115 out of 530, and then subtracted off the 49 out of 530. And that's how we get the 404 out of 530. And so divided by 530, that's about 76%. Now A and B, that's this intersection. That's where the overlap is. So this is simply the 49 out of 530. That's both things happening in one selection. And 49 divided by 530 is about 9%. So A given B. So I've narrowed it down to just the people who are 55 or older. So basically, I'm only considering this group. Now, there are only 115 people in that group. 49 of them use social media. So this is 49 out of 115. In other words, 49 divided by 115 is 43%. Now, if I say B given A, I'm only considering the people who use social media. So just these 338 people. And there are 49 who are in the age group 55 plus. So this would be 49 out of 338. So notice that the denominator changes depending on what was given. So 49 divided by 338. And that's about 14.5%. Okay, so next I want to see if these are independent. So I need to compare either the probability of A given B and see does that equal the probability of A, or alternatively I could have asked does the probability of B given A equal the probability of B. Well, the probability of A given B is 43%, and certainly that does not equal 64%. So these two things are not equal. Or I could have compared these two things, which are also not equal. So are A and B independent? The answer is no. So in these examples, we've used most of these. All of our answers were between 0 and 1. Let's see. I've used the complement rule a couple of times. I didn't use the addition rule for disjoint events, but I used the general addition rule, the conditional probability. For E and F, let me just point out something before I finish this. The probability of E and F. So, or in this case, let's say A and B. So I know that that is 49 over 530. And I want to show that that equals the probability of A given B times the probability of B. So A given B was 49 over 115, and the probability of B was 115 over 530. Notice those will cancel out, and we'll get 49 over 530. So that kind of illustrates this rule. And we did the test for independence. If you wanted to illustrate the addition rule for disjoint events, we could say, what's the probability that you would pick somebody 55 plus or 18 to 34? Those are disjoint. Someone couldn't be in both of those. And so then we could just add 55 plus was 115 out of 530. And 18 to 34 was 150 over 530. And so that would be 265 over 530. So that's the additional for disjoint events. All right, I hope that helps you understand the rules of probability. See you next time.